Okay, intermediate value theorem. We're at 2.8.
Last part of chapter 2. There are three big theorems in calculus. This is one. We call it the IVT. Now on, we'll just say IVT. The other one is the MVT, and then you have the AVT. Okay, so that's all. Those are the three big theorems for the year. We're gonna have more than that, but they're the ones that you really have to be zeroed in on. Okay. The intermediate value theorem. So first of all, you have to have a continuous function, right? So let's say you have an airplane. Here's the airport, right? Okay, this will be a time. This will be distance. Travel. If it takes off, is there any point at which it's going to skip a value and start a new one? So it has to be a continuous track, right? Airplanes don't just disappear and appear somewhere else. So an airplane has to have a continuous track, right? So that's condition one. It's continuous. There we go. That's much better.
This goes down, you crash.
So it's continuous, right? The airplane doesn't ever skip the spot. What the intermediate value theorem says is at any time, there will be a corresponding distance, right? That's all the intermediate value theorem is. At any time, or any x value, there will be a y value. At least one. For an airplane, it would be one. For mathematical purposes, it might be more. But, that's what the intermediate value is. And can you find the x or the y value corresponding? So that's all we're looking at today. Does that make sense? No. It is a result of continuity functions. So if this function is continuous, we know that because for every y value, there's an x value, at least one x value. Here's one way to use the intermediate value theorem. I'm going to do this example, and then I'm going to write the theorem out formally for you. So I'm going to kind of give you an example first. So let's prove that sin x equal to 0.3 has at least one solution. Are you asking Michael? No. You just have to show that it exists. That's what the intermediate value theorem does for us. Okay. So The question is, are there values of sine around 0.3 that give us x values? So, we want 0.3 to be between these two. So 0 and 1 are good candidates, right? What sign is that one? Pi over 2? So we can see, since this would be our problem, our statement of proof. Sin x is continuous, and point 0.3 is between those two y values. There exists an x between 0 and pi over 2. Or which sin x 0. That's what the intermediate value theorem does for us in general. Could we find that x value? Yeah, you bet we could. We need to in this case. No, we don't.
What if we chose a different, like we chose 0 and 1, what if we chose 0 and 2? Would you do that?
Well, sine does not define it.
Oh,
Right. Sine goes from -1 to 1. So we could have chosen -1. But you do want to be somewhat close to it. So graphically, remember sine looks like this, right? So basically we've said between, here's 1 and pi over 2, right? Here's 0, 0. Between here and here, 0.3 is crossed at some x value. That's all we've said. And that's what the intermediate value theorem does for us. Because f is continuous, and these values bracket both ways, we're good to go.
that's like,
So let's write out the theorem and formally. It's good to be used to this stuff. So this is IVT. If f of x is continuous, on a closed interval, remember what closed interval is? It includes A and B. The endpoints are included. And f of A does not equal f of B. Then your book uses n for the y values that we tried to find. So for every m between f of A and f of B, there exists at least one value C. Remember what that means? C is some number inside of A in the interval. It's an X value inside of A, B.
So it's either A and B then?
No.
No.
See how the brackets are open? It cannot be A or B. So they're open brackets. Such that F of C equals M. So this is how theorems are worded. We've never really worked with them because geometry has been dropped from post curricula, which is kind of a shame actually, but we're still going to do it. All right. So basically what we're saying is you have A and B, right? And you have some function f that's continuous across that closed interval. Here's f of A. Here is f of B, right? For every m, so anything you pick here, it could be up here or down here, doesn't matter where. For every single one of those, there is at least one C or an X value that corresponds with that Y value. That's what we're saying. Okay. That's what that says. Graphical purple. Okay. Let's see. Does that make sense? Like the airplane example, right? Everywhere between, this would be our A, this would be our B. It's continuous, right? There's a time related to every distance. So that's the mathematical theory, perfection, goodness, whatever you want to call it. So can you see how we used it to solve this problem? Okay, we have an A and a B, 0 power to our interval. And then f of A, 0 is 0. F of power 2 is 1. We found that because that's just continuous, the theorem says that point 3 is between those, we have a value. We can find that value, but this says, is there a value? Yeah, there is. We're done. Thank you.
Will we ever have to find the value in our homework?
If you're applying the mean value theorem as a concept, probably not. Okay. Now, we will use this in derivatives to find values. We just won't say because of the iterative value. Okay. So, as a theorem, we're using it in this manner. Okay, there's something you can do to find zeros using the intermediate value theorem. Okay. You don't have to. Okay, this is for really nasty, ugly functions. All you can say is, yes, there's a 0, and it's in this interval. So something like this. Show that. This is so nasty, I was being copied right out of the book. We're going to show that function has a 0 in
2. The interval. Locate the 0 accurately. Yeah. Using the bisection method. The bisection method is not especially important, but it does help you zero in on 0. Focus in on the 0. So, is F continuous? That's condition 1 of the IDT, right? I sure hope so. You can't use it in either. Yeah. Okay, is that function, okay, is cosine continuous over 0, 2? Is sine continuous over 0, 2? Okay, so yes, it is. You can say it's continuous. You don't have to prove that it's continuous. Okay, we know that these are continuous on 0, 2, and I showed you the laws that allow you to combine those. So yes. Okay. Now, what is F at 0? The cosine square at 0, 2 sine 0, 4. So that is, what's cosine at 0? 1. 1 squared is 1 minus 0. And sine of 0, 0. So we got 1, right? What is F at 2? This is probably going to be a calculator exercise here. Make sure you're in radians mode. Remember that? Because I have math for some pretty comp students that are probably not going to be in radians mode for a while. Math 4, ever. Pretty calc, we get radians mode for the last. So what are these values? That should be a 2. Cosine of 2 is or what? Okay. And then what's 2 sine of 1/2? Okay, so we're going to get negative 123, 17. Yeah? Yeah. Okay. So, what do you notice? What? Holy cow, I can add. Whoever said yeah? Gosh. Quit disagreeing with me for giving you a candy bar.
You didn't give me a candy bar, you took that away.
I didn't take it away. You left it.
I said no, which is the same thing as taking away.
No, it's not.
Yeah,
Never yours to begin with, so I can't take it away.
got him. You probably want it. Is that what she was supposed to do?
Probably. Did we do our calculation wrong?
What is it?
He said it's a different answer in the book. Did you square the 0.4? Okay, cosine at 2 is what? Okay. Square. Square it. So, yeah, it's gonna be like 0.2 something. And we're gonna get that. Yeah, negative times negative. And we're going back into the And then, what was the answer, Brandon?
So approximately negative 0.706.
Okay, so it's still negative, right? So we go from a negative y value to a positive y value, what has to happen? And therefore you have a 0. So if you see a sign change, you know you've crossed the x-axis, right? One of them's down here, one of them's up here. What has to happen with a continuous function? We have a 0. Okay. So, so on the AP exam, if you say this, they automatically think you're including continuities. You don't have to say both of them. Let's say by the intermediate value theorem, F is 0 in so if you're pre-responding, saying this is enough to include this material. You show the work, you implement the intermediate value theorem, make your statement. Now, if we want to narrow in and focus in on that 0, what's halfway in between here? 1. So what's halfway 1? Your calculator. Okay, it's still negative, right? And 0 is positive, right? So we know now, because of that, our 0 is in this interval, right? Okay, now try f of 1/2. Because we're going halfway in here, and it's going to tell us which way to go. This is called the bisection. So what's f of 1/2? Positive, right? And this one's negative. So it has to be between 1/2 and 1. See how we're kind of slowly chopping away? You could do 1 next. 3/4. And then you could, if you wanted to, you could cut that in half and you get really close, so you never find it. You get really close. So we know it's in 1/2 and 1. I don't know how far you go. I'm pretty sure I signed one. Usually they'll say to an interval of size 1/4 or something. Yeah. Okay. That was part of your answer. Yes. So you have 2 questions here. Show that f has a 0 and 0, 2. Okay, that's done. That's the intermediate diagram. Then locate the 0 more accurately. Okay. Let's see. Yeah, it doesn't say be more an interval of size something. We'll do that. Okay, any questions? Pretty straightforward. Big idea. Showing the math, not very hard. We will see this theorem again and again and again. You will get it memorized. Okay. Yeah. We'll get the condition memorized. So you'll get better at reading theorems. Very loosely. Not the same question, I guess. Prelims and exercises. I'm used today as much of a spiraling day as new material day, so,
I want
right. So you got 3 sections of spiraling. That's the APU on your test, get practice from those sections. Just be pretty proficient at continuity and calculating limits. And you're gonna do this stuff.
to back your phone down.
Oh. Hopefully it wasn't $75,000 call I've been waiting for.
What that would,
Yeah, that would be awesome.
would be awesome if I'd have answered it.